In this video, we're going to be talking about how to solve quadratic inequalities. So it's going to have some similarities to solving quadratic equations or quadratic functions, and then we're just going to see how it's different when they're inequalities instead of equations. So let's just start with a review example of solving a quadratic equation. Okay, so this quadratic equation is in standard form, which means that I can either use the quadratic formula to solve it, or I can try to factor it. So let's go ahead and take an attempt at factoring it. First, I'll set this equation equal to 0. And then if I want to factor this, I'm looking for two numbers that multiply to -3 and add up to 2. And two numbers that will do that are going to be 3 and -1. So I can factor this into x minus 1 and x plus 3. Okay. Once it's in factored form, then I just take each factor and set it equal to 0. So x minus 1 equals 0. X plus 3 equals 0. And I'm just going to solve for x. So x equals 1. And x equals -3. Okay. So what we're going to do in this lesson is that we are going to take an equation just like the one we just solved, and instead of having an equal sign, we're going to change this into a greater than or equal to sign, or a less than or equal to sign, and we're going to see how to handle that. Okay. So let's just look at this first example. Here we have, in example A, we have the exact same equation that we just solved, except for instead of having an equal to f of x, we have that function is greater than 0. So basically, if we look at this graph that I already sketched in for us, we're looking for places where the equation is bigger than 0. That means that we're looking for things that are above the x-axis. Okay, so all these values that are above the x-axis are the values that we want to catch in our answer. Okay, so I'm going to show you what we do on a number line with this. So if we want to sketch this solution on the number line right underneath, we basically look at these 2 points where we are touching the x-axis, which in this case are -3 and 1. And those are going to those are going to be important points on our number line down here. I'm drawing them in with open circles, and I'll explain to you why in just a second. And basically what I want to do is I want to highlight all the parts of this number line down here that where the x values of my graph are above the x-axis. So I'm kind of looking at my graph above, and anywhere where it's green up there, I want to highlight down here. So basically, this graph is going to go in infinite directions, both to the left and the right. It's going to include everything except for those middle values. The reason that I included open circles here instead of closed circles is if you look back to my original inequality, this is a greater than sign. It's not a greater than or equal to sign, which means that I am not looking for values where my function equals 0, just where my function is greater than 0. Okay. So the final step to this problem is that I want to write my answer in interval notation, which means I also want to have like a numeric representation of this number line. And the way I do that is I basically look at each of those red chunks that I drew on my number line, and I'm going to write kind of like a domain for them. So this chunk on the right is going to go from -infinity all the way up to -3. And then this chunk over here on the right goes from 1 all the way to +infinity. And whenever we have two different chunks of domain like this, we always put this union sign between them, and it kind of just means and. It means that I have two pieces of domain. It's -infinity to -3 and 1 to infinity. Okay. Let's see how this changes just slightly in the next example, when all I'm going to change is I'm going to change this to a greater than or equal to sign. Okay. So again, if I look at my graph, I'm still looking for the values where my function is above the x-axis. So it's still going to be these upper values. But because I have this equal sign, it means I'm also looking at places where my function actually equals 0. So it means I'm also going to include those x-intercepts. So if I jump down to my number line down here, it's going to look pretty much exactly the same as the number line I just did, except for now, my circles are going to be closed circles. Okay. And as I write my my numeric representation, it's going to be from negative infinity up until negative 3. And now I'm going to put a bracket. Remember that bracket means that I'm including the negative 3 in the group of answers that work. And then I'm going to go from 1 to infinity. Okay, so I still have a 2-chunk domain there. Now the next example is actually just the equation. F of x equals that x squared plus 2x minus 3. And we already solved this equation. And if we look on our graph, we're looking for places where our function is actually equal to. So we're just going to have 2 points. Those 2 places where my graph touches the x-axis. So x equals negative 3 and x equals 1. Okay, we don't usually draw number lines for answers like this because they're just 2 numbers. Okay. All right, let's go ahead and work again with the same equation. We just want to look at what happens when now my inequality is saying when the equation is less than 0. Okay, so here I'm looking for where is my function smaller than 0 or beneath the x-axis. It's going to be all this part of the graph underneath. Okay, and since it's not less than or equal to, I'm going to have little open circles here at my x-intercepts. So as I shift down to my number line, I'm going to have these 2 open circles, and I'm going to highlight the whole number line between those open circles. Because if you look at the graph above, it's all those values between negative 3 and 1. Those are the values that are giving me the function beneath the x-axis, or smaller than 0. And then to write the interval notation here, I'm just going to go ahead and use those endpoints. And it's going to be parentheses instead of brackets because I have open circles. Okay. And you're probably catching on and know how to do the last one by now. So again, we're looking for the values where our function is less than or equal to 0. So it's going to be all these values beneath the x-axis. Since I have that equal to sign, I'm actually going to fill those dots in. And down here on the number line, I'm going to highlight this whole chunk between negative 3 and 1. And then my interval notation, which is what these brackets and parentheses is called interval notation, is going to be from negative 3 to 1, and it's going to include negative 3 and 1. So we'll just write that down, interval notation. Whenever we say we want the answer in interval notation, it means we want like kind of the numeric representation, and then we can also ask you to sketch a number line. So on some problems we'll ask you to do both. We'll sketch a number line and do the interval notation, and sometimes we'll just ask you to do one. All right, let's go ahead and take a couple looks at some other examples. So one thing that was nice about these examples is that first of all we use the same equation for all of them, and I actually gave you the graph of the equation. So it was easy to find those x-intercepts, the places where it's crossing the x-axis. But in most cases, I am not going to give you that graph. I'm going to expect you to be able to come up with that answer on your own. Okay. So here are a couple steps to how you can solve this. So the first thing you're going to want to do is you are going to want to solve your inequality. Okay, so by solve, I mean I want you to find what the x-intercepts are. And that's basically going to tell you where are your circles. We don't know if they're open or closed yet, but it's going to tell you where the circles are in your number line. And then you need to decide if that parabola would open up or down. And then you can just sketch a super, super rough sketch of that parabola. Okay, it just needs to be going the right direction and have the right x-intercepts. And then you can use that information to finish drawing your number line. Okay, so let's just do a couple examples. I think it sounds a lot harder than it is. So if I look at A, I have x minus 3 times x plus 1. This is in factored form. So I'm just going to go ahead and solve each of these pieces. So one of my zeros is x equals 3. And then the other one is x equals negative 1. Okay. So what that tells me is that down here on my graph, the kind of like key points down here are going to be negative 1 and 3. Now I drew them as open circles, but let's just go back and see if they should be open or closed. Since my inequality has an equal sign in it, these circles are going to be filled in. Okay, so we have these two open circles. Now we have to ask ourselves, is the part that we want the part between the two red circles, or is it the part to the left and the right of the two red circles? So to kind of think about that, what I am going to do is I'm just going to sketch a super rough graph of this parabola. So I know I have an x-intercept at -1 and at 3. And I know this parabola is opening up because my a value is positive. So my parabola is going to look something like this, right? That's not a perfect sketch. If I wanted a really good sketch, I would find like the vertex, the y-intercept, and all that stuff. But all I care about is seeing which part of my graph is above the x-axis. So since I'm looking for where is a function bigger than 0, I just want all of these values that are above the x-axis. Okay. So once I have this really rough sketch, I can kind of just translate that down to my number line and say, okay, the places where my graph is above the x-axis are those places to the far left and the far right of my graph. So that allows me to kind of sketch in the number line as needed. And then I can use that number line to write my answer in interval notation. Oh, I already made a mistake. I'm going to include a bracket here because I have a closed circle. I am actually using and including that point. Okay. So if you look at example B, that's going to look very similar. I'm going to jump down and do some examples that maybe don't look quite as easy maybe as the one we just barely did. So let's go ahead and do example D. So example D is x squared minus 4x minus 12 is less than or equal to 0. So this equation is in standard form. So if you want to find your two x-intercepts or your two zeros, you either need to factor it or you need to do the quadratic formula. I would recommend trying to factor it if you feel comfortable factoring. But if you don't, then go ahead and do the quadratic formula. This one will factor into x minus 6 and x plus 2 because -6 times 2 is -12 and -6 plus 2 is -4. So finding two values that multiply to our C and add up to our B. Then once I have these two, I'm going to use these two factors to find my x-intercepts. So x equals 6 and x equals -2. And those are going to be my key points down here on my number line. So I have -2 and I have 6. And I drew those as closed circles because the inequality I'm dealing with has an equal sign in it. You can't really tell the way I circled that, but it has that equal sign in it. Okay. Now I'm going to go ahead and just sketch a super rough graph of what this would look like if I were just plotting it on an xy plane. So I have an x-intercept at -2, and then 1, 2, 3, 4, 5, 6. So I have those two x-intercepts. And my parabola, again, is opening up because my a value is positive. So it'll look something, that's pretty sloppy, but it's going to look something like that. Now, because this inequality is less than or equal to 0, I am looking for places on my graph where this function is beneath the x-axis, or it's smaller than 0. Okay, so it's all these values between -2 and 6. So if I translate that down to my number line, I'm just going to shade in everything between -2 and 6. So that means that as I start writing this in interval notation, I'm going to include everything starting at -2 and going up until 6. And I'm putting brackets on both sides because I'm including both of those endpoints. They're closed circles. Okay. So there's a lot more examples you can work on here. I will do another video working through a couple more examples so you can see some more.